Okay, sounds good. Waiting for 20-second countdown from CCTV. Hi, I'm Bob Doyle, the information philosopher, recording and webcasting from my ITV studio here in Cambridge, Massachusetts. And today's topic, up on our big screen, will be my task of separating free from will and responsibility from punishment, whether that punishment is retributive or consequential, as I will explain. Separating free from will is a problem that's an intrinsic part of the very idea of free will. Famously, John Locke said, "Don't ask whether the will is free, because the will is an act of determination, of self-determination. Instead," Locke said, "think that the man is free, the agent is free, but the freedom comes from that agent's ability to come up with new ideas that have not been predetermined by anything that happened in the past, in the sense of a causal universe in which all the events in the world, including all our human thoughts, are predetermined from the earliest times in the universe by reason of the laws of nature, when the laws of nature are thought to be completely causal." Physicalist philosophers like Jaegwon Kim describe this as causal closure. There is nothing outside of the material world, which Kim calls a physical world, but I differ. I believe that there is another realm, so to speak, in the physical world, which is not material, not matter or energy, but instead is what I call information, and that's why I call myself the information philosopher. It's a fairly simple argument, and that is that everything is made in terms of its atomic matter and the possibility of energy in that matter by matter and energy. We are composed materially as matter and energy. That's not the case, though, when we come to the arrangement of that matter. The arrangement is different from the arrangement that occurred at the beginning of the universe, which was basically totally chaotic, an extraordinarily high temperature, so dense, so high temperature that there was nothing resembling even one single atom at that time. It took a while even for there to be neutrons and protons, which are the nuclear particles in an atom, and the electrons, which are another part. Instead, the universe was enormously hot. It consisted primarily of what are called quarks, which we now know to be the sort of sub-elementary particles that create the nuclear material of neutrons and protons, and the electrons, and a massive number of photons, which are radiant energy, pure radiant energy. But there was nothing that you or I, could we look into it, could see in the form of a structure that carried information different from pure chaos. That creation of the first atoms didn't occur for hundreds of thousands of years after the origin of the universe. Up until that time, the universe was a haze of photons bouncing off of free electrons, which had been occasionally bound with a nucleus to become an atom, a hydrogen atom, the simplest of all atoms. But as soon as that electron and proton got together, they were blasted apart by this surrounding radiation field, enormously high energy. And nothing interesting could happen, nothing could form like an atom until the temperature had fallen from enormously high temperatures down to around 5,000 or 6,000 degrees, the temperature of the surface of the sun that now provides all the energy for life on Earth. At that time, something very interesting happened. The universe became transparent to radiation. Hard to realize this, where before this time, which was around 380,000 years after the origin, the universe was a brilliant haze in all directions, just bright light in all directions, extremely hot, like sitting inside an incredible oven, not a 300-degree oven like which is really around 600 degrees absolute, but a 5,000-degree oven, a temperature that would melt almost any material, or we could think of it burning it up and blitzing it and separating the electrons from the material atom so as to have a kind of an ionized plasma, it's called, extraordinarily high temperature and no ability to maintain even a few atoms. That changed when the universe became transparent, because when electrons bind to the protons, they no longer scatter all light photons. Instead, atoms only selectively interact with photons. When photons are high energy photons, they approach X-rays and very high powerful photons. They can then ionize the atoms, but when the temperature's fallen down to of the order of a few thousand degrees, the light we now have has also reddened, relatively speaking, and cooled down, relatively speaking, to lack the energy to ionize ordinary neutral atoms. At that point, atoms only interact with radiation selectively by, for example, absorbing certain discrete spectral lines of photons. And that's the beginning of a story that's going to involve Albert Einstein, Max Planck, who studied the curve of all radiation and showed how it changed for different temperatures. And we'll pick up a lot on that story on Friday when we get into our lectures on Albert Einstein. But for now, I just want to say that as an information philosopher, I am building a story of how the universe began with this extraordinarily high temperature, and when it expanded, it cooled off. And it cooled down until the point where it suddenly became transparent. We could now see photons coming to us from across the universe. Now, there wasn't any we to see yet. That's going to take another 9 billion years. But something exciting begins to happen, something interesting begins to happen about 400 million years after the beginning of the universe, which I describe as a creation phase, but I like to point out a creation with no sign of a creator, where there is no mentality at this time in the universe, there's no plan, no blueprint, but there is, in fact, now a lot of room where the distribution of material has some unevenness. In some places, the density of atoms, which is basically all we have at that time, is higher than it is in other places. And that gives the very weak force of gravitation an ability to pull together vast volumes of material and attract them to fall into centers like the stars, or even the large swirling collections of stars that are the galaxies. And so what we have at this time is the creation of information structures again, which we see them, we see our sun, the moon, our planet, and we realize the galaxies are made up of large numbers of stars, plus a lot of dust and gas, which hasn't itself collected together under gravity because it's still pretty disorderly. But this event, around 400 million years, is the end of what I would like to think of as, or near the end of an era in which what's going on is the creation of information structures but they're passive information structures because they have been entirely created by natural forces, beginning with the nuclear forces that created the neutrons and protons, and the electrostatic forces and quantum interaction that leads to our atoms at around 380,000 years. And then 400 million years later, the weak force of gravity pulls together these wonderful things which are our galaxies and our stars and our planets. But at that time, every one of those objects has been basically created because of random distributions of the original material. Now, it's important to emphasize the randomness because there's no plan here, and it's also important to emphasize that we now have objects where we didn't have them before, and the reason we can now have them at that time is because the universe has expanded away from its extremely random and disordered beginnings. Today we see a little bit of order in the form of these galaxies, stars and planets, are information structures as I described them, but they are all formed by random events following physical laws like gravitation, electrostatic and quantum processes, and the nuclear forces. There is no such thing as any entity that's putting this star here, that star there, with a planet or without, and a galaxy which is full of possible planets with life on them, we speculate today. But we now wait 9 or so billion years, and we come to a time when our particular star, our sun, has formed, because formation of these stars and planets has been going on for billions of years after the very first ones were possible. And now the universe has expanded enormously. And it's now populated with lots of stars which have started to shine out of a very dark universe. In the time between the first formation of galactic objects, around that time, things have been very dark because there was no source of high temperature energy like there had been at the beginning of the universe. In any case, at around 3.5 billion years ago, half a billion years maybe, or some small time, relatively small time after the formation of our sun, the light falling on the Earth provided the energy for some small entities, which were made up of combinations of atoms, so they'd be called molecules. They began to accidentally, at the beginning, duplicate their information. And this marks a very important moment in the history of the universe, because now we have these little entities that are replicating themselves. It seems to me this is the beginnings of proto-life. And the reason I want to call it life is because the process of creating another identical entity, identical at least in the fact that the arrangement of their atoms is exactly the same and they form the same macromolecules. We can't really call them anything yet like a biological molecule, nothing near a protein, or let alone the wonderful complexity of our DNA, which contains the information about who I am, and everything from the smallest cells, the archaea, the bacteria, very simple singular entities, one-cell organisms, up to the eukaryotes we are composed of, which contain much more elaborate life forms and so forth. All of these now contain information, which information is being used to create the next replicated version of this proto-life. And that marks the time when information is involved in the production of more information. We've reached this kind of second level in terms of information. Before that, I want to call the galaxies, the stars, the planets, the rocks and asteroids, or anything out there, I want to call them passive information structures because they've been formed by other forces. Whereas now we have little objects that are using their own information to duplicate themselves. Now that will become very sophisticated as we move on and come up to where a cell contains the information on how to divide into two cells and make more or less identical copies. Copies are never perfect, though, and various events, including high energy radiation coming in from the universe now, destroys the information, produces errors. And these errors will come to be thought of as the variations, the random chance variations in the information content of living things. And that change, that chance-caused change in that information may lead to an improvement in that particular living or proto-living thing, and that would lead to a possible motion up the scale of life to where, all the way up to us. My story is a very simple story. Information is involved passively in those objects that have been created by simple physical, natural forces, laws of nature. But then, when information starts to involve itself in the producing of additional proto-life and then finally living things and complex living things and more until we rise up to the animals and human beings, information is involved, and that to me marks the appearance of what I could even call a proto-mind, but I want to get to mind in the third stage. And in the second stage, we can just say that that information seems to represent purposeful behavior. That is to say, living things seem to have a purpose. Jacques Monod's colleague in winning the Nobel Prize for elucidating DNA, Francois Jacob, liked to say, and very nicely, the purpose of a cell is to become two cells. Well, simplistic, you might say, nothing like the drive that we're going to attribute to animals and human beings, the kind of purpose which is full of intentions and thoughts and so forth in a mind, but it is nevertheless a distinguishing feature of what I regard as the second phase or stage of the development of information in the universe. In a single phrase, I think the first stage is creation. The universe was created, continues to be created in the information sense, because creation just brings the universe into existence. At the origin, we have a mystery behind how it appeared at a certain time, which many philosophers and theologians have speculated on whether the universe was infinitely old, or perhaps it actually had an origin and there was a creation. I believe my work in information philosophy and cosmology can show that there was a creation, and it is continuous creation. That is to say, in the information sense. Every day there is more information in the universe, despite this horrible second law of thermodynamics, whose tendency to disorder, the notion of entropy increasing unavoidably, seems to be in total conflict with my picture of the universe as creating information, which is thought of as negative entropy. How can all these negative entropy, pockets of negative entropy in the universe be here and be sustainable against this law of thermodynamics? That's my work in information philosophy, to explain that right down to the level of the thermodynamic properties of anything forming, and the role of quantum mechanics in providing possibilities, without which possibilities there can be no new information, as shown by Claude Shannon, the great developer of the mathematical theory of the communication of information. But building on ideas that go back to Ludwig Boltzmann, Shannon argued that with no possibilities, there can be no new information. Because if there's just one single possibility for the future, then you can say with the Laplace demon picture that one can know the information at one moment and it stays the same indefinitely, no new information. Now that's a view that was very sympathetic with and or believed by many to be consistent with a supernatural being who had a master plan, a book of the universe, and the entire universe was already written in that book, which is to say, going forward, I may think I have free abilities to think up new ideas to talk to you about, write new books, which I think contain new information, but I'm mistaken, because the universe, if it is this notion of constancy of information hidden somewhere in a book, in one metaphor, then the universe is basically totally determined and contains no possibilities for human beings, and things like free will, consciousness, purpose are erased, and they're thought to be illusions. They're thought to be some trick that our biology is playing on us and making us feel as if we have a mind that is in control of the creation of information. So, in a word, that first phase, starting with the extremely hot origin and an expansion, I call that creation, but without a creator. No evidence of a creative mind. And then the second phase, in which life appears, I'd like to think of as evolution without a designer. No sign of an overarching design, a mentality that has a vision and can see the way the universe and or life on our planet in the universe will develop over time. I see no evidence of that designer. Instead, it seems perfectly adequate to have a model, a Darwinian model, of some kind of blind, not seen variation by mutations of the DNA, and leading to a natural selection, a kind of retention of certain selected properties in the next set of living things, as evolution takes us from so simple a beginning to wonderful and beautiful things, which are amazing, as Darwin appreciated perhaps before many of us when he saw how that could be done by such a simple combination of a possibilities stage followed by a selection phase or a choice phase, although we don't want to talk about it as a choice in the sense of a mind, because there still is not a mind visible in my model. But that mind does come to be, and clearly we see it at the end of the evolution of the higher organisms, animals and human beings. And so I'd like to categorize that stage of life evolving to involve mind beyond just purpose entering the universe, because we can attribute purpose to cells who are striving to become two cells and to keep themselves alive by sustaining their energy needs. Basically every cell depends on a flow of negative entropy, of radiative energy coming in, whether it's into a plant or especially into a plant, because those create the foodstuffs for the things that are higher up in the evolutionary chain. We human beings cannot photosynthesize our energy and depend on just having a certain amount of sunlight every day. Instead, we've evolved to the point where we have to eat some other form of life, digest it, and then take that matter coming in and the energy, which, as I say, has to have negative entropy. Erwin Schrödinger first pointed that out to us by saying that life feeds on the negative entropy of the sun's radiation. But in any case, how do we get to this point where we think about this third level as having a mind? Well, my characteristic of it is to notice that the mind, our thoughts, from those high-level thoughts all the way down to the ideas or the information that's encoded in different life forms coming forward, those are all abstract information. They are embodied in matter. The information in the earliest forms of proto-life is abstract information. It's embodied in the matter, but it isn't the matter. And similarly, as we move on up the biological evolutionary scale, we find organisms that have information which is now used to basically direct actions of these higher organisms until we get to the point where we have a mind. And our mind, which is embodied in our brain, I see as a way for larger organisms like ourselves to record their experiences. From the beginning of their life, they are recording experiences, and they are put in the mind, especially in humans, in this incredibly complex and enormous neocortex, which is a terrific storage system, and it has a capability to recall the information which has embodied our experiences in this brain. And I now have a picture which says that organisms that learn from experience can add what their repertoire of behaviors is to the one that comes along through their DNA. In other words, we have a genetic inheritance, and then we have a developmental capability to learn. And learning consists, in my information-based model, in that set of experiences which we store away in our neurons of our brain. We basically store them in a very simple model, first suggested by the neurobiologist Donald Hebb, that what happens is, in our earliest experiences, we see things, we hear things, we feel things, and they get recorded because the neurons that are firing when we are experiencing, okay, at all times when we are experiencing, even as an infant, neurons are firing. We can see this happening today with our wonderful MRI tools and our, we don't see them in very much detail, but we definitely see these neurons are firing. And what Hebb said is the ones that fire together, chosen at random out of this enormous multiple billion connections between multiple billions of neurons, each with 10,000 dendritic connections to other neurons, this whole complex apparatus is firing, and the firing is totally dependent, partly at random though, on what experience appears to us. And to me, it's much more than just recording visual and oral and the five senses. To me, we are also recording at every moment the feelings that we are having, our emotions, the amygdala, and that part of the brain which goes way back to animal brains and maybe down to reptilian brains and so forth. That amygdala is experiencing sometimes fear, sometimes pain, sometimes pleasure, sometimes joy, and that recording alongside the experience provides the growing, learning being with the context needed to provide meaning and interpretation to any new experience. Okay? So let me kind of home in on this. Let's say we think about the first experiences of a newborn. Then loud noises frighten them, and they shake, they react. That may be built in. That may have been a genetic hangover, holdover, genetically handed down from a past ancestors through the genetic material. But other things they may experience, and it's hard to say what they might be, but the first appearance of a ball, for example, the question arises, what does the recording of the experience of seeing a ball amount to for that infant? In my view, it's more than the simple information, the way people think of information as just a kind of a sterile set of bits and bytes of data that we put into a computer today. And indeed, I accept the criticism that information seems a little thin to build a world of understanding where we fit in nature. But since I've identified information coming from the before life and then during life being so critical to the ability to evolve higher and higher organisms, I would like to make information very critical at this stage of what it means to have a mind. However, anyone who's studied this, especially I think of David Chalmers, whose hard problem of consciousness was featured in my very first lecture, almost 46 lectures ago. Chalmers says, look, we can understand information being stored. We can imagine information being perceived in the universe. And that's all pretty simple. We're aware of our surroundings. But how can that possibly explain the subjective, the personal, the emotional feelings aspect of consciousness? And I agree with Chalmers. If we were just putting stuff into a computer, we wouldn't be giving that computer consciousness, despite our goals of creating artificially intelligent machines. But instead, I am now proposing that I have a model which records experiences and then reproduces them and plays them back later, so that we have the context that we need when we see similarities in new experiences to old ones, and then we can consult the feelings that have been recorded with those older experiences. And if the old one was a fearful experience, and we get a new experience which has even a small part of the original experience, and the old experience plays back, and it produces that old emotion of fear in its reproduction, we now have, beyond the Chalmers concern that information alone cannot explain the very powerful notion of consciousness and so forth, because now I can say that we have, in fact, a way to feel the importance to us as an individual subject who's grown through experience to be a certain kind of person. And I hope that will appeal to people. The important thing here is, though, for our work today on freedom of the will, which this is our topic today on Tuesdays, free will. My book on free will is basically putting forward an argument that we are free and not previously determined, predetermined by events coming up to today. And I want to put that new freedom in the context of this model of the mind that I'm describing to you. Because we have the same accidental changes over time are possible in forming new species, I want to take the Darwinian model of evolution, which involves new information, put it into our minds and imagine it as William James did, basically looking to the model of Darwinian evolution and applying it to what he called mental evolution. And here what we have is that when confronted with a decision point, when you're coming up to a situation where you have to decide what to do, William James is basically telling us it could well be that new ideas pop into our minds. And all that's needed for that in physical terms is for the mind to be susceptible to quantum noise, which it undoubtedly is, because the little storage items that are holding the information are relatively very small. Some argue the neurons are too large to have quantum noise. Our brains are too big to be involving anything like quantum limits and so forth. I believe they're completely wrong, and we can very simply argue that quantum effects are accessible to the human mind for the simple reason that evolution has taken itself all the way to the quantum limit in demonstrable ways. In particular, for example, the eye has evolved to the point where it can actually detect a single photon, a quantum particle. The nose can smell a single molecule, distinguishing its characteristic information from others, where the other is only different because of its shape, because of the way the molecule is put together out of atoms. This is, of course, really very powerful proof that an information structure, as I call it, has potential causal effects in the world. The simple fact of smelling a molecule which smells like gas, I'm using the term, gas that we use in our gas stoves and so forth, would suddenly frighten the person into saying, I better get out of here and not strike a match or I'm likely to blow up the house. Very powerful sequence from mere detection of information all the way through to a very powerful action. That's my information model for the mind, where that capability comes from recording experiences. Just to make the point, a young child who'd never smelled gas, doesn't know what it does, has not had the experience to realize that this is a dangerous smell. That smell hasn't been recorded and then reproduced, played back as stimulating the amygdala to give us the feeling of fear. That's the entire story. I take it from Donald Hebb, who said that neurons that fire together on original experiences are wired together, and I basically turn that around and argue that those neurons that have been wired together in the Hebbian view will, upon being presented with even a portion of the whole experience. It's enough, for example, that the smell of gas, which is recorded in some past experience, which wasn't a pleasant one, or the sight of smoke, which usually is an index in Persian symbol terminology. It is an index or pointing to fire, and that similarly may reproduce a previous experience, which then will motivate and drive our actions. Okay, so what do we need to be free and will, or free will? We need the ability to generate random possibilities if it's to be a creative act of free will. And those random possibilities can come from our past experiences. If some of them are genuinely random in the sense of involving quantum processes, which I believe I can prove as simply noise in our neural connections, which distort an old idea and produce a new idea, which for the most part probably will be a crazy idea, one that we wouldn't act on, or maybe something we just suppress. But if a new idea is generated, in part by having this total indeterminacy, so no predeterminacy from the past, then we have created what William James called alternative possibilities. But that has absolutely nothing to do with our ability to will an action based on that freely generated new possibility. So separating free from will is to recognize that we are free to create new ideas. And then we look at those possible ideas and evaluate them against our character, against our motives, against our feelings, against our desires, against our complex of things that make us a human being, things that I, in my third stage, want to call not just a mind. My model for the mind is this experience recorder and reproducer, but beyond the mind, we have a spirit, we have a soul, we have a self. Many modern philosophers basically argue that the self, the soul, the spirit, what Gilbert Ryle called the ghost in the machine, are all illusions. There is nothing going on in the human brain that is other than material, they think, obeying laws of nature. When they become materialist in this way and deny immaterial mind, my abstract information stored in the brain, when they deny it, they basically reduce us to our matter. They make arguments that we are natural beings and follow natural laws, and those natural laws don't allow us to be anything but completely determined, and so naturalists think that we don't have all of these attributes of a self and a soul and a spirit and a mind, which, however, I seriously disagree, and I'm trying hard to build such a model. Now, as to the deterministic need, the need for our will to be a determination, and I emphasize that we should call it a self-determination. That self-determination should be adequately determined. We don't want that determination, except on special occasions, to involve chance anymore. We want to reduce the role of chance in an act of will. We want an act of will to be willed to an action, thoughts that are considered, possibilities considered that lead to an action. That's a different business from creating them in the first place. Creating them means freedom. Willing to act on those thoughts is a self-determination, which is an element of free will, but it's distinct from the idea of first creating the possibilities in the first place. Okay, let's say we've separated free will from free from will. And basically, I want to propose that we consider 4 different kinds of separations on my page on separability in my book. Let's take a quick look at the book. And I will zoom in, give us a close-up view, turn to my chapter on separability, and here we begin by proposing 4 degrees of separation. We separated just now the free from the will, where free involves quantum indeterminacy and complete independence of the past, from will, which involves an adequately determined, determined in the sense that the process of evaluation is not susceptible to random noise, although some have pointed out it may be necessary. Dan Dennett pointed out, and Bob Kane also, that there are times when we don't have enough information to make the decision, and we flip a coin, or indeterminacy enters into the choice. So the next phase that we need to discuss today is separating responsibility, or what we could call accountability, from moral responsibility. That is to say, this is a decision that our fellow human beings in our culture would judge to be a moral or immoral act. Okay? So I also then want to separate free will from moral responsibility. And then I want to separate free will and moral responsibility, taken as a general subject area, from the problem of punishment, whether that punishment is retributive or consequentialist, which are interesting questions. So the fundamental assumption of our 2-stage models for free will is that we can separate free from the concept of will in order to better understand free will, as John Locke had recommended. And I started by noticing his statement that I think the question is not proper whether the will be free, but whether a man be free. And then I provided a kind of an analysis of this problem of separating free will from moral responsibility. And to that end, I think I'd like to go to this page. I'll just zoom over here, scroll down, and I'll give us a colorful version of this. Whoops, lost everything. Oh my goodness, I closed out my browser completely, and I'm not sure I can get back into it quickly. Let me try to do so. But once again, I want to tell you that all of my work, let's go to a full screen with this, is to be found on my Information Philosopher website. There were my books. I would hope you would learn to navigate this website. On the left side, you'll see my large number of philosophers and scientists, all of whom I hope you might read, or many if you're interested in these particular individuals and what I try to give you in terms of their work. And at the top, I have a number of drop-down menus, and since we're on the subject of free will, I will touch that free will. We now enter the section of the website called Freedom, and down the left-hand side here, I can make it a lot bigger, I have a number of the concepts that are involved in understanding free will. And They are very technical in some cases, so causality is an issue. Determination and determinism are important issues. Many other explicit issues each have their own pages with a lot of resource material for you. But what am I looking for? I'm looking for not Laplace's demons or the mysteries of free will, but finally we get to an area where I'm going to talk about semi-compatibilism, which we did last week, on the idea that free will is compatible with determinism, which I disagree on, and then separability. So let me go to separability. Here we are on the page we introduced. I hope you'll learn to drive around this way. And we scroll down and we're back to where I lost everything a moment ago with this analysis of how to separate it. So let me take another moment and see if I can, I guess this is good enough. I'm going to put this up on my screen behind me so I can kind of talk about it a little bit. I can bring it to full screen this way. On the left, I have the problem of free will. On the right, I have the problem of moral responsibility, which I basically think is a separate problem, which I can divide below into the responsibility aspect, whether we can trace the beginning of an action to an individual, right? Accountability. And on the right, the notion of morality and whether moral problems are involved. Then we can descend into the question of morality, moral behavior being, immoral behavior, I should say, perhaps being punished, okay? And then the question becomes whether this punishment was so-called retributive, that is to say, was done to get revenge. Historically, the reason for punishment being acceptable in a society is the so-called eye for an eye. I've been harmed by this person, and I want to harm that person back to get even, so to speak. Today we have a lot of progressive, we could say, thoughtful, liberal attitudes towards an individual who harms us. And society likes to say, well, there may be deeper reasons behind that person's actions. Those destructive actions may have been consequences and caused by earlier events like a horrible childhood and so forth. And in those circumstances, we want maybe to modify the level of punishment. And instead, we can go down this path on the right side here that is called consequentialism, and that limits punishment in our society to, well, for one thing, we could incarcerate an individual who's regarded as out of control and unable to control primitive instincts to harm others, psychopathic behavior and so forth. But here we're talking about, even in the case where that person may or may not behave badly again, we nevertheless may choose to punish them because the consequences of punishing a certain act educates other members of the society to avoid such behavior because they're likely to be punished. And that's called consequentialism because it produces better consequences in the society. Okay? I just wanted to add restitution, which I've always thought is an interesting addition to the society's obligation to help the hurt individual. It should be somehow, maybe out of general taxpayers, rather than a person who might have no means to do this. But if there's been a loss, like an eye, the goal would be to restore that eye or that capacity. If it's a monetary loss, then they should have a monetary payment and so forth. That's the picture of responsibility, including moral responsibility, that I want to propose should be held apart from free will, because responsibility is a social question and a cultural question, and that's evidence for that is that there are so many different rules in different cultures around the globe today, and over time in the past we've behaved very differently with respect to things that are regarded today as crimes. Some of them we decided aren't crimes anymore in some societies, but they're held to be crimes in others, and so forth. So that wide divergence of opinion suggests that this is not a scientific question about something that's a property of the natural world. But over here in free will, the part about freedom, okay, which I have here on the very left, needing indeterminism, okay, and generating alternative possibilities, this is very much a question of science. Is science completely deterministic? Is the universe tracking along one and only one path? Then freedom is out of the question, because it's basically the opposite of freedom. And if this were to be the case, then I would agree that free will is an illusion. We would instead be acting, but the actions are really being put on us by natural laws. So then I divide the will in this section, and I insist that that be described as determination but not predeterminism, okay? And I have this phrase, adequate determinism, because it turns out determination may, in many cases, still involve a certain degree of randomness. Perhaps accidentally, because an accident appears in the middle of our decision making, or because we seek out a random decision because we don't have enough evidence to decide that one or the other alternative is the better choice. We may then literally flip a coin or mentally just go with one because we go with the flow, and we probably couldn't say afterwards why we chose vanilla instead of chocolate today, but we would have the feeling that we did it freely because we don't feel as if our actions are being controlled by some other agency or by laws of science and so forth. So, okay, with this picture, we're separating free will from responsibility, including moral responsibility, and we're coming down to a picture that says we need to think this through because we can still decide as a society whether we are going to punish people, whether just to get even, for revenge, or whether we're going to go punish people just because we think it improves the society to have a set of laws that puts people away for a time in order to re-educate them. And maybe I should have a little section here that says rehabilitation is a form of education, and some societies have their prison camps full of re-education and indoctrination. I can't go there and make a judgment necessarily, but these are issues that are very important issues bordering on politics and broader social questions of what kind of a society do we want to live in and be and so forth. Very big problems in the world today. I have some hopes, if I can live long enough, to get out there with ways of thinking about what we are as human beings that would educate young people before they're indoctrinated in their own set of beliefs that their society has today, might liberalize a lot of people and give us a better society for all to live in. Okay, so I think I just want to say that I'd like to name a couple of the people who are kind of involved in this question, and ones we've discussed a bit recently, but let's just remind a few of them. To begin with, I'm basically saying that free will is a scientific question, and moral responsibility is a social and cultural question. And I hope many of you can see why I'm making this distinction. And I find, however, that people out there who call themselves compatibilists, the leading ones are philosophers we've addressed in separate lectures. On our Wednesday lecture on individuals is Dan Dennett, perhaps, and also John Martin Fisher. So I say, to clarify the relationship between free will and moral responsibility, we have to look at them. Like some philosophers, John Martin Fisher is an example there, deflect the direct discussion of free will and study it only as what they call the control condition for moral responsibility. Others, Dan Dennett, argue that free will is moral responsibility. And it's the only free will worth wanting, he says in his book, Freedom Evolves, and Elbow Room. So, at least, however, Fisher and Dennett agree that moral responsibility exists. And I praise them for that, because we should be trying to work on educating our young people in our lectures on philosophy as to what constitutes a good life, a moral life, and so forth. But it can't be done on by science alone. I've been taught for many years, since my undergraduate years at Brown, that science has a very limited role in ethical discussions. I think they should be broader than what I was taught 50, 60 years ago, but I accept the notion that science has a limited role, but one of the big roles is to declare that that freedom that we see is in fact based in physics. And the idea that physical laws of nature are determined has just always been an invention, a mistaken invention by thinkers who didn't understand the world as we now understand it today at the fundamental reality. Now, by contrast, many other thinkers, and here I cite Galen Strawson and Derek Pereboom, I spelled his name incorrectly there. Let me go back to that page and tell you what I'm talking about. By contrast with Fisher and Dennett, Strawson and Pereboom, and Saul Smolansky, they argue that there is no moral responsibility for the simple reason that they don't accept quantum indeterminism. Some of them who do even recognize quantum indeterminism then come up with, let me just change this screen to the same thing here, they come up with the argument that if there is any randomness involved in these things, then we are random and we can't be morally responsible. And that's, unfortunately, they're not very clear thinkers. I'm not arguing that the randomness of quantum physics is affecting our every move so that our hands are jerking and we're basically not in control of anything. We obviously are in control. The role of randomness is simply to provide us with alternative possibilities, each of which can be evaluated in an adequately determined way to make our will phase of free will. However, it's sad that there are many thinkers who argue that randomness destroys free will and determinism in the will step also basically denies any free will. They tend to also be people who call free will an illusion, along with consciousness as illusion, and the self is an illusion. There are no egos. There are just natural objects obeying laws of biology and chemistry and physics. Well, I disagree with that, of course. So here I have a paragraph on naturalists, and if you go to my blog, which is at i-phi.org, you'll find that I've prepared these notes ahead of the lecture, and when something is a blue link, like the misspelled Pereboom link, you can travel away from the blog and into my web pages and find a great deal more on these questions. So basically, I see I'm scrolling down, and here's yesterday's lecture, which I didn't quite finish. So why don't I look to close out this talk today by turning on my little musical background and say that I have a threefold view of the story of the universe from time zero to today in three important steps. The phase in which we created the stars, the galaxies, and the planets, I call creation without a creator. There's absolutely no sign of a mind with a plan behind the random formation of galaxies and cosmological entities everywhere. And in the next and most dramatic phase, I want to start with the formation of life, and I call it evolution without a designer, because there's no sign that there is any kind of overall thinking process beyond the use of information to create new information in more advanced life forms, which are emergent, and it's the emergence also of purpose. And finally, I imagine the final stage of the thinking person to be mind without a soul. Not that it lacks a soul really in a self, it just lacks an immortal soul. So I hope you will be with us again. Tomorrow we're going to look into Bob Kane, the leading libertarian. And I see everything's running well.